Hi gang, today we're going to be talking about paradigms, the scientific method that we will be learning throughout the semester and you'll use the rest of your career. So, what is conceptualizing designs? Well, number one, it's about understanding the nature of the problem and problem spaces. When we think about a problem space, what we're trying to do is first identify what the user needs. What's the information, the data they're trying to get, or the task or the goal that they're trying to get to? To do this, we need to understand what they exactly want by questioning them. And we have to examine the best ideas and the inventions that are already out there. We have to understand that if there's already an interface that we can use and adapt, we should be doing so. Interactive product design is actually about usability for the user's experience. It's about ultimately meeting their goals, not ours, understanding what they want or our client wants to meet their expectations. Problem spaces are interesting because the first thing we think about as coders and designers is the fact that we should never assume something. Don't assume something is wrong, number one. Ask your user, is this working for you? You need to compare functionality and goals. If they're having problems understanding something, or their language isn't correct, or maybe you're using the wrong color, or the writing is the wrong way, or maybe it's too small. Think about how many times you've seen senior citizens try to read something, and the print's so small they're using what? All different aspects. Are holding the book up close to their face. They're using glasses. They're using little anything they can, contraptions. Today we have interfaces such as the iPads that you can, what? Squeeze and make the text larger, quick. We have haptic devices that actually work the field. There's braille writing for visually impaired people. So we need to actually look at and compare and organize the errors that we're recording and seeing in our observations from what is stopping the goal being achieved by the users. So conceptualized designs do a couple different things. First, they orient the questions to the task and goals. It helps us understand what the user's tasks are really about. They have us look at things open-minded. We don't look at things so that we narrow it down to where it's unusable or too large to where it's unusable. But we have to think about the scope. Don't make it too limited. And don't take it to where only we want it to be. We have to be open-minded to listening to our users. Let them express what they want. We have to put things in common terms and languages, not only so that the users understand things, so that other scientists or other people like us or other coders know what you're talking about and trying to do. Why? Well, it reduces misunderstandings, common language. Think about this for a second. If we're working for a company with most of the users are speaking Arabic, would you want to code everything and use everything in English? No, we'd probably want to learn Arabic or hire someone to help us understand the cultural differences in the languages so we don't offend somebody. We want to outline everything to make sure that everything that we use is a benefit for the users. It's called mapping for the user's experience. And we want to be smart. Adapt things that are already out there so we can use them and make our creations better. If they already know how and have learned to use one device, maybe we adapt that device, their comfortability, and what they're comfortable with into our own personal designs. So it's a design concept. We have to think of a set of ideas. And usually we look at scenarios to where the users are doing things. Look at their behaviors and the outcomes, and actually assess those behaviors and outcomes in those scenarios to discover where the errors are and the problems. This will help us find easier ways to get to those goals for the user or make sure their tasks are accomplished. Think about the star interface. It's one of the first kind of models that came out by Xerox in the early 80s. They looked at secretaries and trying to change them over from analog platforms into computerized world, and they decided that, you know what, they're already frustrated, scared with this box in front of them, so they had to redesign it. So they took it offline. They started thinking about what they actually do, what their goals were, and how they did these tasks. And so they started making familiar knowledge to them in the computer interfaces designs. metaphors, if you will. We'll talk more about them. So they created representations and icons like paper clips. What do you do with a paper clip? Well, you put multiple things together. So when they gave them this, they started understanding, oh, if I put a paper clip to this, I can put all this stuff together. And then they put it where? In a file. Remember those yellow manila envelopes we used to use all the time? How about IBM's interfaces? What have we seen in Microsoft's designs as symbol? Oh, the yellow folders. Folders go where? Inside the filing cabinet. This is where those concepts came from out of this design. So they created these screen properties that match the physical counters in the real world. Screens were actually thought of then as a cabinet space in a lot of times. So every time there's a window, they started thinking of, oh, it's a different drawer. They used these desktop metaphors in operations, and they created the electronic folder system. Think about Apple today. Theirs is widely used everywhere in the trash can. What did they do with the paper? They adapted this idea. You want to get rid of digital data, you put it in a trash can. Their first computers, because they got slow interfaces, were frustrating to people. So they thought, well, if we put up, every time somebody's happy, a big smiley face computer, people will be more relaxed about the interface having time to actually compute and do the tasks that you're asking it to do. As soon as they changed this emotion and behavior from the user and seeing, okay, this is a friendly computer guy, they were happier and they let it work. So interface metaphors and designs are a concept that hasn't gone away and continuously changes and evolves and is adapted today. We're using familiar entities. We're making explicit positive behaviors in our users. Let's think about my favorite, Amazon. What do? Well, I go around through the internet site pages and I put things in my shopping cart, just like I do at Walmart. I browse and I put the things in the basket, and if I don't like them, I can move them to where? My saved items, or my, as I used to do at Kmart in the old days when I was a kid, you put it on the wish list, so you can hold it in the back and pay a little bit now or wait for later. These are visual objects that orientate us the same thing as real world today. They're metaphors. We use these because they create ease of learning. They connect us with things that we're traditionally used to doing, the same thing in the computer world. Think about a calculator. The first calculators that came out on the internet were these complicated device things. Nobody understood what they were. And someone thought, well, why don't we make it look like a calculator? And as soon as they did that, calculators were added to everything, and everybody understood the design and enjoyed it. So there's 4 types of interactions we should really be familiar with in our mindset and in our journals. So instructing, this is, issuing instructions. When I was a kid, you had to do everything. You wanted to start the computer up, you had to know how to write an instruction to get the computer to launch in DOS. Then there was conversing. This is that idea where you have a dialogue back and forth with the system. We do this as coders. If you want X, then you do Y, and it creates something. You can manipulate. This is more today with the interaction in a virtual reality. We're going to look at some of this and exploring through physical space and 3D designs. So the instructing is typing commands, using those keys, selecting options. Today we use speaking commands, Siri. We can use gestures as well a lot of times in the virtual reality world, and quick function keys. Think of something simplistic we've all used for years, the Coke machines. You walk up and you see Diet Coke, Coke, regular Coke, Cherry Coke, all have big buttons. You put your money in, you instruct it by touching the choice that you want in the button, and the machine does what? It spits you out a Coke. Conversing is a dialogue. It's a two-way effect. It's that Shannen and Weaver model we'll get into a little more, to where you have a sender and a receiver, and you may have noise in between that stops it, just like your cell phones today. Think of the Verizon commercial. Can you hear me now? Can you hear me now? Someone's calling you. If you're in a location where your phone doesn't pick up reception, you can't hear them. It's a break in the model, the communications model, the same as our computers work today. If the user is not able to add the information that they want to get the data out, it stops. This is essentially a query-based idea. We do this in all types of activities. Think about the banking industry. You walk up to your Mac machine, you put your card in, you select your secret password, and you may say, "What's in my account?" You type a query for your checking account, it shows you your balance. Or e-tickets. Everybody has done this now to where you buy an airline ticket online, or maybe you go and buy a rock concert ticket online, or a hockey game. Excuse me. One of the most interesting things I saw recently was a virtual reality representation when I got off the plane in Atlanta. I wanted to rent a car, so I took the train to Hertz rental cars, and I walked up to the counter. Instead of a human, I found an interface, just like I'm talking to you now. We're conversing in dialogue the same way through this computer, an interactive device I'm using, a software. Well, it had a virtual person's face. I picked up the phone, I started talking to the person, I ordered the car that I wanted, I explained what I'd like and what options, and lo and behold, keys spit out. They charged my card, told me where the virtual station was to go and get the car itself and the keys and unlock it, and I did, and by dang, 10 minutes later, I was driving down I-75. Pretty fascinating. And I don't know where this representative was, but they were able to converse with me virtually and get the car that I wanted, and even tell me where it was parked, and the keys were shipped to me through the computer. So manipulating is the kind of third display. You know, we move, select, open, close, zoom, stretch, shrink, squeeze. As my little nieces love, when the first iPad came out, she would put her finger down and I'd put mine. I said, okay, pull it apart. And when we did that, it would shoo. It would make it big, or bigger eyes, as she said. And we'd put them together and it would shrink and squeeze them. And we'd do this, and it was so fun, she'd giggle and laugh. But these are interactive manipulating designs and interfaces today. We all use them. You're interacting physically in this world with different manners. Same thing we do today. You'll look at different clothing and hold them up in front of you, but today we can go online and you can pinch and zoom in and zoom out to see if you like how the design of a pair of shoes is, like I was doing the other day on Zappos to see if I wanted to buy the new running shoes. I turned it virtually so I can see the sole. It's a learning aspect that we've already understood, so it helps us in the computer world. Why do we do it? It reduces anxiety. When someone's anxiety-filled or stressed, they leave the interface. And that's exactly what a client doesn't want if they're trying to sell you shoes. Think about Apple. Their direct manipulation software, such as in the iPads, has changed and revolutionized the world. It is essentially a new paradigm. It's a paradoxical shift in the way we use interfaces we'll talk about. So exploring is another way where we move through in virtual realities. I have and set up before a Second Life account to where I went in and transitioned through cities and landscapes. I went to a virtual art opening once. Bought virtual paint by using Bitcoin. It's interesting to where today the virtual landscape has a whole monetary society. Think about Apple's value. They're transcending the banking industry by using Apple Pay. You can buy iTunes. I bought 2 or 3 things. Songs, I bought a book. I bought multiple things just through my virtual reality essence on my iPhone. Today, hospitals are training nurses. Sorry, gang. Oop. And different surgeons virtually. They're teaching them just like we used to do in the old days with erector sets, to where you would go in with a little pair of pliers and try to get the heart out, and it would shock if you hit the size. Well, today, the same type of things are happening virtually with training. 3D, and Oculus goggles you'll see soon. I'm going to show you a little clip on that. Take a look at this piece just for a minute. This is fascinating to me about the resources out there today. This is
Virtual reality is about to enter the operating room. Breakthrough technology is being introduced today at a gathering of neurosurgeons in Washington, D.C. Only on CBS This Morning, Kara Fincham gets a sneak preview from the inventors in Southern California.
Virtual reality headsets are already revolutionizing the way people experience video games. Put on a pair of goggles and you can travel anywhere from outer space to the battlefield. But gamers aren't the only ones. This technology can transport to new worlds.
It's just amazing to see every little opening in the skull where a nerve goes through.
At the University of California, Los Angeles, neurosurgeons are slipping on virtual reality headsets to go inside their patient's brain.
I'm virtually inside the skull of the patient, walking around, floating around.
Dr. Neil Martin is the chairman of UCLA's Department of Neurosurgery.
I think this is going to have a tremendous impact.
He's developing this virtual technology with Modi Avasar, a former officer in the Israeli Air Force who designed flight simulators for F-16 fighter jets.
How did you get from flight simulation to virtual brain surgery?
We allow the pilot to fly through the sim of tomorrow's mission, and that's exactly what we're allowing brain surgery.
Avasar started out creating 3D models of the brain for computer screens by combining elements of flight simulation software with traditional brain scans. Now Avasar has taken that technology to the next level with this virtual reality headset. Put it on.
Yeah, it looks like you can almost reach out and touch them.
And you fly around inside the brain, moving past brain tissue, nerves, and blood vessels by simply moving your head.
Now you can turn your whole body.
Okay.
It's like being there, inside the vessels, inside the brain.
Oh, wow.
Brain surgeons often operate on tumors and aneurysms dangerously close to areas that control language and movement. They do it through a microscope and an incision the size of a dime. This technology would allow them to practice before the surgery, and during it, they can put the headset back on to reorient themselves.
Here's an example. Right here on the image, I can see the carotid artery going through the margin of the tumor. Rather than have that all of a sudden appear as I'm removing tumor, I'll know exactly when I'm going to encounter it. That is a big improvement.
An improvement that he believes will ultimately benefit patients by making surgery shorter and more successful.
Go ahead and put that on.
Lucas Dinas is looking at a tumor recently removed from his own brain.
So it's like the convergence of gaming and life saving.
Dr. Martin has used the scans of former patients to practice using the virtual technology.
We're still waiting for flying cars, but now we have flying surgeons.
And within weeks, he plans to be the first neurosurgeon using these virtual views to save real lives. For CBS This Morning, Cara Finstrom, Los Angeles.
Love this.
Yeah.
And this is what makes me exciting about our show. We're constantly looking at where the future is.
Yeah, agreed. I mean, can you imagine the possibilities that opens up for surgeons to be able to have like that?
Sorry, gang. So pretty amazing right there. Brain surgery, virtually. So one of these things we've got to start talking about is scientific terminology. Paradigms, theories, models, and framework. This is a scientific exploration you guys are going to go on and learn about and use the rest of your career. So paradigms are essentially a set of practices that the scientific community has agreed upon, and they frame everything out so everybody uses the same questions the same way to make sure the outcomes are tested equally on a phenomena. So a phenomena is essentially, we think today, the iPhone could be a phenomena in our paradigm, the computing paradigm overall. And we all can look at this and observe it. We can test the way users use it by observing how they do it, and we can sit there and say, okay, we're going to watch how Dr. Spangler uses his iPhone in class. We'll all observe it the same way sitting in our seats, and we can analyze the data we all discovered and interpret if there's anything different, and then present our findings. Kuhn was one of the first ones who come up with this idea of a paradigm back in the 70s, and it's suggested through a great book of his that I suggest getting, but about paradigms and paradoxes. Two of the things we should think about in terms is WIMP, Windows icon menus and pointer. You'll hear this a lot in GUI, graphic user interfaces. Are kind of some of the key elements and phenomena that changed our paradigm in our world. When a paradox happens, or a shift into thinking, we start changing something. And when I try to explain paradox, I say first, let's think about a paradigm. So everybody thinks about the world in their view. And we've all done this. And we first saw the idea the world was flat. That was a paradox. Everybody believed the same. And if you went so far in a ship, you would fall off the end of the earth. Then all of a sudden, we discovered what? A paradox, that the world is actually round. And sailors saw this because they got back to the same point. Science extended in a new paradox our world and our universe. So everybody starts thinking, well, there's one universe, you can keep going and maybe you get to the next, we don't know. There's only one plane here. Well, scientists such as Michio Kaku, one of my favorites, has come up with a new shift and a paradox in that paradigm, thinking of the M theory. If you watched The Big Bang, you probably heard them talk about the string theory. This is where the shift in that came from. The string, if you think about a piece of string, is usually multiple cords wound together to make one piece for strength. And to where they thought there was only X amount, 6, 7 of these strings that intertwine to make our world. Well, the M theory says there's many different worlds right next to us, little slices. So maybe there's someone standing right next to you, pretty scary, or maybe there's 40 people standing next to that person. And then there's another 400 in the universe. The slice is infinite. So we have to start thinking beyond the tech, desktop, and user interfaces. We have to think about the context of the user in our designs today, the social, the emotional, and the environmental. To understand this, the ubiquitous computing idea, so that it's unobtrusive in use. It's disappearing. Think about that idea we just watched in that video. What happened? The innocuous goggles were placed on by the surgeon, and instantly he was inside the brain, moving around, up, down, wherever he looked. The exterior universe, the environment, was totally gone. He was able to socially and contextually look only at what he wanted to look at through that brain or the veins that were going through. His emotional connections to the outside world were left, and he was inside of that paradigm itself. He was creating, in essence, a paradox because it was an exploration of where we've never seen ourselves, and surgeries in medical institutions. So these theories are a set of practices used to analyze and predict. Well, we worry about performance or users' expectations. Is the interface accepted by this? Can it be changed? We think about cognitive theories and representations. Are we putting out too much or limiting the amount of information? Sometimes we limit the amount of user expectations and possibilities because we don't think we can handle it. We also think about social acceptance in our interface designs. Again, back to that idea of if we're creating somebody who speaks Arabic. Is it socially acceptable to have pictures of, let's say, women driving if we're making an interface for Saudi Arabia clients? No, they would probably be offended because in their culture they don't do that. In our culture here in America, it's just totally acceptable. It's actually ignorant to think differently, but in theirs are very traditional in different ways. So we have to think about culture and traditions and acceptance and language and color. Does red mean stop or anger? Does it green mean go and good? Or does it mean something else like yuck? Like in my kids' day, green was yuck. It's just recently it's healthy because it's used in everything organic. But prior, if anything was green, as a child, I was told, don't go near it. So we've had to change this and think about our limitations. So models are very interesting pieces that comes out of these theories. So where once you have a set of practices that can be replicated, you get a model, a way to analyze the data or the user's abilities or what they're doing. It then allows somebody else to repeat your study, execute the same actions, and evaluate your outcomes on the actions. And say, yes, I agree with it, no, I don't. Or further your research. Look for that new paradox in a paradigm. Norman has a 7-stage action model, which I'll show you a piece here in a second on him. He's very interesting. He has a couple great books out on interactive design, emotional, cognitive, relationship of design and people. Everything from the handle of a teapot to the way you hold your pen. I particularly like one type of pens because I've grown to love them, the way they feel and the way they make my hand feel when I'm writing so they don't hurt. I asked you guys to look at a pencil prior, so it's interesting. Another thing is we can think of an easy way is keystroke models. There's actually a process to where you can sit and analyze a user's performances as they do something on an interface to determine whether or not it's the most effective method to reaching their goal. We can count keystrokes for how many keys it will take me to get to YouTube, or how many ways I have to open up a different document and find different ways to do this, and find more effective ways for the user as myself to do something. This is a keystroke model. So I'm going to show you a piece by Norman real quick. It stopped and I still have it up here. So I'm going to show you. He's one of my favorites. I really enjoy him.
Hi.
Hi.
Don Norman.
I'm Don Norman.
I've just come back
to the University of California at San Diego to start the design lab.
Over the years,
I've done a large number of things. I've taught. I was a vice president at Apple, startup companies. What we spend a lot of time on in design is trying to understand the real needs of people. And for this, we don't ask, we watch. Because what people think they need is often not really right. So we try to watch and understand what people do, how they use the products or services we're talking about. And then there are many factors that go into why you like something. In the last century or so, science has placed huge emphasis upon logic and rational thinking, and that's misplaced. We're not logical. We're emotional.
There are two kinds
of things going on in the brain. One we call cognitive, which is trying to understand the world, but the other is emotional, which in many ways is more important. Because what emotions are about assigning value. And value is what's of critical importance to us as human beings. So as a simplification, we said there are just 3 levels of emotion. One we call visceral, which is automatic. We're born with it. So we like sweet tastes and we don't like bitter tastes. The second is behavioral, and that's, well, how we use something, how we learn to understand it. Can we predict what's going to happen? Do we understand? Does it feel good? The third level is reflective. It's the most conscious. The other 2 are subconscious. But the conscious level is where we think back about what we did, whether we liked it or didn't like it, or evaluated it. Look, emotion is a very powerful system in the body. And to say that we reacted emotionally instead of intelligently, that's wrong. No, there's an emotional intelligence. The most favorite objects that we have are ones that have a story, that have an emotional attachment. So people might love, what's their favorite teacup? It's this old teacup that's even cracked. But especially if it was handed down from your grandmother to your mother to you, yeah, it tells a story. And it's wonderful when it captures the mind and the heart and the body, and that's what people cherish. Design is all about fitting people's needs, and our needs vary. Sometimes we need something that really works well, and I don't care what it looks like. And sometimes we want something that just makes us feel good. We might buy a pair of shoes that are really uncomfortable, and we just love the way they look, and so we don't care. We'll suffer the discomfort because it makes us feel good. Some things maybe should be more functional and efficient, and some things more warm and loving and emotional. We need this balance between the two. I've written many books, but I wrote one entire book on emotional design. But I also write books on how to make things that people can understand and actually use. And we have to do both.
So, sorry about that little blip there, but when we're talking about different designs, we can look at everything from 2 different cognitive representations, as he was saying, in the emotional, which is the most interesting. And you're going to have to think about a lot of this today because everything is emotional. We have to think about the relationship and design. Designer's model is how it should work, how we think it should work. The system image is how it actually should work. And the user's model is where we have to stop. Do they understand both these aspects? And do we actually meet their requirements? We have to think about their relationship and interaction with the designs we create today. We have to think about the framework. Frameworks are the explicit relationships between how the system should function, how it's presented to users, and how it's actually understood. If a system image is not clear, the user can't really work with it. They don't understand it. They get frustrated. So we have to think about that structure. We have to have a plan for it, a strategic plan through the evaluation of what they want, questions, and their outcomes. And we have to place it into a scope. We also have to make sure it's simply designed and can be evaluated following these scientific models. So Shannen Weaver was one of the first ones who thought about these communication and relationship designs. And I was saying about if we have a user, or let's say a cell phone connection, your mom's trying to call you, your dad or your neighbor or somebody, and you're not in a location to where you have reception, you might get that Verizon aspect. Can you hear me now? There's a break, there's a noise in that communication level. There's a loop that we must complete. The sender must send us the message. We must be able to receive it without any noise, distraction, breaks in the communication, and send back an answer to complete our goals. So if we think about this, we actually have to think about simplistic communication models and everything in languages. Are we having everything that we need to have there? All the pieces fitting together. So let's look at a little thought on communication model.
What exactly is communication? The most simple definition is that communication is each act of transmitting information. Information in the broader sense of the word, including thoughts, ideas, and emotions. Giving someone a bouquet of flowers is communicating a certain message. Adding to that gift a verbal compliment, you're pretty, is another separate act of communication. Blushing because you've just received flowers and a compliment is again another form of communication. As social animals, we communicate day in, day out with spoken words, non-verbal gestures, signs, and symbols. Sometimes we use media to communicate a message. Media are the channels that we use to communicate. Scholars don't really agree on the definition of the word media. Television, internet, radio, mobile phones, the soapbox we stand on to give a speech. They're all technical media in a way. Things we constructed to amplify our communication. In the more broader definition, we can include our hands, voice, and eyes that we all use to communicate somehow in the list of communication channels, of media. In general, however, whenever we discuss mediated communication or the mass media, we only mean the first category. Over the years, scientists from different scientific disciplines have studied these channels of communication and all these different forms that communication can take. The result of their studies have formed the basis of the relatively new science of communication. And even today, many scholars in other disciplines study the exact same communication phenomena as we do. We share theories and models and often use the same methods to analyze and describe our field. It is therefore useful to be aware of how these other disciplines are connected with ours. To get an idea of the different levels of communication and how they are connected to other scientific disciplines, we can look at the so-called pyramid of communication. On the highest level of this pyramid, we find societal communication, which is by its very nature aimed at a large mass audience. Therefore, mainly historians, political scientists, and sociologists study this perspective. Under that is the level of institutional communication. It's performed by political parties, for instance, organized religions, large corporations, and such. Then comes the level of group communication. Groups are audiences that feel a high level of group identification. For instance, a family or a fan club. Both institutional and group communication are in the field of sociology and cultural anthropology. We have now arrived to the level of interpersonal communication. Basically, the communication between two or more people. Both sociologists and psychologists study this field. Finally, there's the level of interpersonal communication. This will be the communication you have with yourself. But this will mean all information processing, thinking, internalizing information, and the process of giving meaning to the world around us. And of course, this approach leans heavily on the discipline of psychology.
So a little bit about the communication model. So let's think about this, what a framework is and how we look at paradigms. A GPS screen is in almost every car today, or you can buy exterior ones. And mine is down to the left and hard to see. And I was thinking about this interface. Why do we have to look down and be distracted from the roadway? I was looking back at the virtual flight schools and how they're using virtual reality and heads-up ideas. And this was adapted to the naval pilots so they can have heads-up display of all the aspects of their plane so they don't have to look down while they're flying to try to find their comm equipment or their dead reckoning or anything or their height. It can all be shifted and seen right in front of them on the windshield or on their glasses that they have if it's down. Why can't we do that today? I'm betting the next adapted technology will have a heads-up display for your car. You can do this with your stereo, up and down the volume, the heating. Why not have a click on and see the GPS screen heads up in the windshield? Boom. Click it again and it's down and gone. Think about other aspects to where we can apply this into the nursing field so that people can learn how to virtually, instead of using us as a pincushion, virtually learn how to find veins on arms a lot easier. To draw blood for phlebotomists. I sent my dad to learn how to golf virtually. He goes to a practice clinic that's in a 3D course to where it looks like he's in the environment on a golf course when it's snowing a foot outside in Pennsylvania right now, but he's playing golf. My brother trained as a police officer for intrusion and entry into houses virtually, looking for bad guys and learn how to go around a corner. Bomb detection teams are training to how to look into a virtual reality, how to disassemble a bomb so it doesn't blow up and they don't get killed. So this is adapting additional frameworks that we've already created into creating new and interesting innovations and paradoxes. So our discussion has gotten a little bit broader today. It's gotten a little bit more interesting. I hope you enjoyed it. We'll be moving on to more and exciting stuff in our next chapters and next weeks. We're getting into the emotional connection later on in the class where we listen to Norman talk a little bit about that idea. We'll be talking a little bit deeper about paradigms and scientific evaluations. I hope you enjoyed this lecture. Take a little adaptive idea to yourself, and I challenge you guys in your journals to come up with an idea of an adaptive technology and how you could use virtual reality interfaces today, maybe even here. Maybe we'll explore different avenues to where we can connect as a class. Have a great night, gang.